What's up, everyone? It's your boy JOSHABRAHAM. And just like the title's read, it's the final touch before the exam. So, from what I decided according to my timetable, my final touch is reading from section 1 to 6. So let's read my lab protocols from 1 to 6. Oh, Lord. Principle of extraction. Explain the principle of extraction. Extraction is the process that involves separation of two immiscible liquids or solvents in which we dissolve the required substance that should be extracted into a suitable solvent. Into the suitable solvent, okay? Here, what is the aim of the extraction? I think I this is not the one. I think this is the one. Yeah, that's the one. That's the one. Extraction is based on differential, based on the differential solubility of a solute in two immiscible liquids. A solvent is transferred from phase to another, depending on the relative solubility. By repeated contact between the phases, the solute is progressively removed. Removed from the original solution. The aim of the extraction is to isolate and concentrate the desired compound efficiently. Extract. They're for sure gonna ask this. Extraction is based on the differential solubility of a solutant. Extraction is based on the differential solubility of a solute in two immiscible liquids. A solute is transferred from a phase to another depending on its relative solubility. By repeated contact between the phases, the solute is progressively removed from the original solution. The aim of extraction is to isolate and concentrate the desired compound efficiently. Interpretation. Extraction was driven by higher solubility of iodine in the organic dichloromethane phase compared to the aqueous potassium iodide phase. In the aqueous phase, iodine formed triiodide through interaction with iodide ions, giving the reddish brown color. In the organic phase, molecular iodine dissolved directly, producing the purple color. With each portion of dichloromethane, more iodine was transferred into the organic phase. The extraction was driven by higher solubility iodine in the organic dichloromethane phase compared to the aqueous potassium iodide phase. In the aqueous phase, iodine formed triiodide through interaction with iodine ions, giving reddish brown color. Due to organic phase molecules, iodine dissolved directly, producing the purple color. With each portion of dichloromethane, more iodine was transferred into the organic phase. Now, conclusion. Would conclude that multiple extraction is more effective in extracting the required substance as a result of the repeated redistribution of iodine between two immiscible phase during extraction of each step. Okay, now, mean standard deviation, relative standard deviation. I do have the formula, right? Mean. First, you have to convert the given mass to volume using density. Yeah, it's mass divided by volume, right? Mass divided by density gives volume. Volume times density gives mass. Okay. Yeah. Mean is the sum of all the masses divided by all the volume divided by number of experiments or number of samples. Standard deviation is the square of the lowest value, right? 9097. Yeah, that's the lowest. Oh, lowest minus. Oh, no, mean. Okay. All the values minus the mean squared by 2. Those numbers are pretty. That's the standard deviation. Relative standard deviation is standard deviation by the mean into 100. Absolute deviation is mean minus the theoretical volume. Relative deviation equals absolute deviation by 10 into 100, or relative deviation equals absolute deviation times 10. So it gets to the percentage. Oh, I should remember these. Based on absolute deviation, 10 milliliter volumetric pipette is the most accurate, while 250 milliliter beaker is the least accurate. Higher accuracy for measuring 100 milliliter than 10 milliliter is due to the relative error. For graduated cylinder, it's plus or minus 0.5 milliliters as error. For 100 milliliter, it could be 0.5 percentage, but for 10 milliliter, it could be 5 percentage. So lower the value, higher the chance to have errors. Higher the value, lower the chance to have errors. Relative error. 10 milliliter volumetric pipette has the highest accuracy. 10 milliliter graduated pipette also has a really good accuracy. Plastic pipettes are cheap, not accurate. Graduated cylinder is like, it's moderate accurate, easier to transfer volumes with moderate accuracy. 250 milliliter beaker is a capacity mainly used as a capacity, low accuracy and precision, holding, heating, rough measuring of liquids. Now, whoa, interpretation of volume change during preparation of a binary solution. What can you say about the volume and mass of the solution compared to those of the individual compounds? What can I say? Oh, volume of the individual. What can you say about the volume and mass of the solution compared to those? The volume of the individual components after mixing has reduced by 6 milliliter, which is due to the efficient packing of molecules, resulting in volume contraction. The 2.5 mass discrepancy is likely due to the experimental errors. Water like dissolves like, more efficient packing. The mass of the mixed solution was equal to the sum of the masses of the individual components. Confirming mass is confirmed. Conserved. Mass is confirmed. What the? What the hell? Preparation of sugar solution and determination of the. Okay, oh. This part is pretty fucked up. Hey Siri, set a timer for 30 minutes.
30 minutes, counting down.
Mass of the solution, mass of water, volume equals mass by density. Volume of water equals mass by density. Mass of water by the. Okay. Molar concentration of sugar solution. Number of moles is mass of sugar by molar mass. 15. Okay. Molar concentration is number of moles by volume. Number of moles. Okay. Volume. Uh, 10 into 10 raised to minus 2. What? Are we talking about this? Okay, maybe. 100 milliliters to 1 liter. Whoa, what happened here? What's with the... Okay, this one's I understand. Whoa. 10 into 10 raised, it should be 100 into 10 raised to minus 1. That is divided by 10. Mass of solute by volume of solution. Yeah, that makes sense. 50 by 0.1, 150 gram per liter. Okay, makes sense, makes sense. Mass concentration, mass fraction of sugar, sucrose solution. Now, determination of sugar content in a beverage. It is a phenomenon where bending of light is observed when passes through a substance or medium. Refractive index is a measure of how it bends. Determining the concentration of a solution, especially sugar solution, food chemistry, and fermentation are application for these. Okay, okay. Read the first one. Second one. Distillation. Okay. 250 milliliter round bottom flask. 3 times stopper. 250 milliliter receiving flask. Heating mantle, distillation bridge, thermometer adapter, 2 cooling hoses, vacuum adapter, refractometer, graduated cylinder clamp grease, metal stand, kick clip. The fuck is that? 3 times stopper. Distillation is a separation technique that relies on the difference in boiling point of the components in the liquid mixture. Each component in the mixture boils at its own characteristic temperature. By heating the mixture, the components can be separated based on their boiling point. Distillation is a separation technique that relies on the difference in boiling point of the components in the liquid mixture. Each component in the mixture boils at its own characteristic temperature. By heating the mixture, the components can be separated based on their boiling point. Baby condenser, reduction adapter. That's quick fit, I believe. Where's that thing? That's quick fit. Yeah. Oh, ho, ho, ho. Water goes in from the bottom. Oh no. Now, refractive index. Acetone. Oh shit, I gotta remember the structures. Acetone is 2CH3. C3H6. Oh, CH3. Okay. Water, I do know water. Collected pure acetone by initial acetone. That's for section 2, okay? You gotta just keep on reading. Re- Recrystallization and sublimation. Round 100 milliliter beaker, zeolites, Buchna funnel, 250 milliliter round bottom flask, condenser, heating mantle, glass rod, vacuum filtration setup, vacuum pump, or desiccator, graduated cylinder. Explain the principle of recrystallization. Recrystallization is a purification method where an impure solid is dissolved in hot solvent and then slowly cooled, allowing pure crystals to form while impurities are filtered out. The process relies in difference in solubility. The, the desired compound dissolves when hot but crystallizes when cooled, leaving the contaminants behind. It's commonly used to refine chemicals. Recrystallization is a purification method where impure solid Recrystallization is a purification method where impure solid is dissolved in hot solvent and slowly cooled, allowing pure crystal to form while impurities are filtered out. The process relies on differences in solubility. The dissolved compound the desired compound dissolves when hot but crystallizes when cooled, leaving the contaminants behind, the commonly used for refining chemicals. Now, yield of the benzoic acid given by, okay, sublimation of soiled iodine. Test tube with sidearm cooling water setup, balance, telco burner, pipette, tarred watch glass. Sublimation is a phase transition where solid passes directly into the gas phase without forming a liquid. It occurs when vapor pressure of the substance at a given temperature exceeds It occurs when the vapor pressure of a substance at a given temperature exceeds the external pressure. In the purification, the substance that sublimes is separated from non sublimable impurities by resubliming as a pure crystal on a cold surface. On a cooled surface or colder surface, don't matter. Sublimation is a phase transition when a solid passes directly into the gas phase without forming a liquid. It occurs when vapor pressure of the substance at a given temperature exceeds the external pressure. In purification, the substance that sublimes is separated from non sublimable impurities by resubliming as a pure crystal on a cooled surface. Observations on heating the soiled iodine releases violet vapor while sodium chloride residue remained at the bottom. The iodine vapor resublimed on the cold surface as shiny purple black crystals. The purification Iodine was separated from the residue by carefully transferring both into separate tiered watch glass. The final iodine mass was lower than the initial, indicating purification. That's section 3. That's a big one. Redox reaction. Explain the oxyhydrogen test. Oxyhydrogen test is basically to know if oxygen is produced. Oxyhydrogen test is used to detect the presence of hydrogen gas. In this experiment, hydrogen gas is generated by reacting metal with acid. The gas produced is collected in water-filled test tube and tested by bringing a glowing splint. When mixture of I think yeah. Oxyhydrogen test is used to identify hydrogen gas by ignition. Here, H2 is generated by reaction between metal and HCl. The produced gas is collected in water-filled test tube, which are exposed to a flame. Loud pop indicates combustible H2O2 mixture. A quiet plop indicates mostly H2 with very little O2, while no sound produced when H2 is absent. Okay. Okay. Now H2O2 bomb, big loud bang, H2O2 mixture. Less H2O2 mixture, a plop sound, and no sound. If no sound, then there's no H2 in that test tube. It would most probably be O2. Now the reaction. Reaction of iron with concentrated hydrochloric acid, very slow bubbles were observed. Reaction of iron with sodium hydroxide, no reaction. Reaction of iron with nitric acid, no. 3 bubbles formed. Solution turns slight yellow. Hot bath water, more bubbles and brown gas. Brown gas is nitrogen dioxide. So iron plus gives NO3 thrice. NO3 twice was for what? That's copper. And NO gas plus 2H2O. NO plus O2 gives NO2. Oh, not the half reaction. Don't ask the half equation, please. Slow bubbles visible. Hot water bath. Slight faster bubbles. Nothing else. Now reaction with iron interpretation. Slow bubble formation due to chloride ion. What was the first one? HCl. Okay. Chloride layer that slows the reaction. No reaction. Iron plus sodium hydroxide. Yep. Iron lacks amphoterism. No dissolution in blue bases. At first, bubbles was observed and yellow solution. After heating, more bubbles with initial product NO, but when reacted with O2 NO2 brown toxic gas, it should all be done in the fume hood. Very slow reaction due to lower H plus activity. No reaction due to formation of inert iron oxide layer. Now with aluminium, slow bubbles at first, sudden rapid bubbling, then solution turned gray. Exothermic heat was observed, ended with cloudy solution with white residue. The solution turned milky white. So the first one is, was that nitric acid? HCl. Okay. The first one was HCl. Solution turned gray. AlCl3. Okay. The second one is sodium hydroxide, milky white. And the third one, no reaction observed even after the hot water bath. A 2Al plus 6HCl gives 2AlCl3 plus 3H2 gas. Al plus Al3 plus 3 minus. Oh, that's the. Yeah. Why won't they reply? Mm-hmm. Al2O3. Aluminium trioxide. Al2O3. What was the name? I don't know. So the first reaction, solution turns gray with white residue. Solution turns milky white. Reactions with zinc. Immediate vigorous bubbles. The solution turns yellow, followed by emergence of white smoke. After a while, the solution turned white. Less smoke at the end. The solution turned into clear solution, exothermic. The test tube was hot. Very slow reaction. No, that was for no reaction observed even after the cold water bath. Just a minute. No reaction observed even after the cold water bath. Cold water, hot water, what the? Started with slow bubbles. As time passed, more bubbles with a hint of brown gas was observed. That's for zinc with nitric acid. Yeah, that's zinc nitric acid. The first one is HCl, second one is NaOH. Okay. Zinc readily reduced protons from HCl gas formation. The white fumes are due to HCl vapors and possibly concentrated zinc chloride aerosols. The heat generated shows exothermic. Zinc acts as a strong reducing agent in acidic condition. Zinc shows no reaction. NaOH isn't strong enough to dissolve zinc or form zinc zincates at room temperature was very slow. Okay, zinc is oxidized slowly to zinc 2 plus while nitric acid is reduced to NO, which then forming NO2 in air. This slower redox reaction highlights HNO3's oxidative strength compared to HCl, not under given reaction conditions. Okay, so I think these are the equations they need. Oi, 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 oi. Now for copper. Slow bubbles was observed, slow reaction. No reaction was observed at first, reaction was observed, but after some time, solution turned into a blue solution. At first, no reaction was observed. Okay. After hot water bath, more bubbles forming was observed and brown gas evolution. The reaction Cu plus HNO3 gives CuNO3 twice plus NO plus 4O2, 4H2O, NO, 2NO plus O2 gives 2NO2. Copper did not visibly react with concentrated HCl. This aligns with its high reduction potential, which makes it unable to displace hydrogen from HCl. The slight bubbling are minor oxidations. The reaction, even after the test water bath, the hot water bath shows that CU does not exhibit amphoterism and resilience to alkaline conditions. The blue solution shows the release of Cu2 plus ions after the heating of NO2 as nitric acid oxidized copper redox reaction. Copper oxidized and nitrate is reduced. High activation energy required. Okay. No reaction or very slow reaction. No reaction initially, but after heating with hot water bath, the solution starts boiling. Vigorous bubbles, the solution turns gray. It's for silicon. Oh, silicon. Silicon plus sodium hydroxide plus H2O gives silicon plus H2 gas liberated. Na2SiO3. I don't know that equation. No reaction was observed. After hot water bath, silicon roasted, reacted vigorously with NaOH, producing H2 gas and gray solution due to the colloidal silicates. This this confirms silicon's character and need for activation energy to disrupt its network structure. There's more. Explain the term redox amphoterism. Redox amphoterism refers to a substance's ability to act as both an oxidizing agent and reducing agent, undergo both oxidation and reduction depending on the reaction conditions. Reaction of potassium iodide with hydrogen peroxide. Upon adding potassium iodide, hydrogen peroxide into potassium iodide in aqueous solution, the initially colorless the initially colorless solution turns to reddish brown due to the formation of elemental iodine, and reaction proceeds. As the reaction proceeds, the peroxide remains in excess, and the reddish gray gradually fades, eventually forming colorless. Sure. I'm not sure. I2 H2O2 plus 2Y plus 2H plus gives H2O plus I2. What happens after the addition of starch solution? Few drops of starch and starch, the solution turns deep blue. Blue. 30 minutes, okay. I should be done in 30 minutes. The starch forms an inclusive forms an inclusion complex with iodine producing deep blue color. Chemical equation for the destruction of iodine. KMnO4 with peroxide, potassium permanganate with peroxide, acidic condition. That was basic? Aqueous, okay, basic. Now, the purple solution rapidly turns colorless, accompanied by effervescence due to oxygen gas. Interpretation, not observation. Oh, effervescence, that's it. Accompanied by effervescence. Now, that's a reducing agent. I do not understand the context of what I'm writing without. Explain the glowing splint test. The glowing splint test is a method used to identify the presence of oxygen gas. In this test, a wooden splint is lit and then blown out so that it remains glowing, not flaming. The glowing splint is then instru- in, in, inserted into the test tube. If O2 is present, the splint will reignite, confirming the presence of O2. Chemical equation for thermal decomposition of potassium permanganate and catalytic decomposition of hydrogen. Important second reduction half equation with K2MnO4 as product. Explain the role of manganese dioxide in this reaction. Manganese dioxide here acts as a catalyst, lowers the activation energy by providing an alternative reaction pathway, also regenerated at the end. It's a type of redox reaction where term disproportionation. It's a type of redox reaction where the same chemical is simultaneously undergoes oxidation and reduction, forming two different products. Okay. Explain the term autocatalysis. The self-accelerating chemical reaction where one reaction product acts where the reaction one of the products act as catalyst, speeding up the reaction as it progresses. Autocatalytic reduction of permanganate interpretation. In the autocatalytic reduction of permanganate, beaker 1 shows lower reaction time, indicating the reaction starts slowly but accelerates as Mn2 plus as product of the reaction accumulates and begin to catalyze further reduction. This self-accelerating behavior confess the autocatalysis nature of the reaction. Beaker 2 with Mn2 plus 27 to 12 as the presence of Mn2 plus in the beginning. However, the activation in the beginning lowered the activation energy, thus slowing Mn2 plus acts as an autocatalyst. Autocatalytic reduction of permanganate. So we use the oxalic acid ion. It was H2C2O4. Conclusion: the experiment confirms that the reduction of permanganate by oxalate is autocatalytic. In the absence of Mn2 plus, the reaction starts slow but speeds up as Mn2 plus forms and catalyzes further reduction. When Mn2 plus is added at the start, the reaction proceeds much faster from the beginning, showing that Mn2 plus significantly lowers the activation energy than Mn2 plus acts as effective catalyst, and reaction becomes more faster as more catalyst formed. Therefore, autocatalysis. Section 5. But before I do the section 5, I gotta take a 5-minute break. Hey Siri, set a timer for 8 minutes.
8 minutes.
Let's make it
Counting
8
down.
minutes. I'll be right back, people. 1 hour, god damn it. Separation and complex formation. Just a minute. Uh, a mixture of CuSO4. Separation and complex formation. 250 milliliter separatory funnel, graduated cylinder, glass string rod. Glass, okay. Glass string rod, okay, whatever. Separation of benzyl and copper to sulfate. It's performed through multiple extraction. 5.01 grams of benzyl mixture was dissolved in 30 milliliter each of deionized water and each of deionized water and ethyl acetate in 250 milliliter beaker with thorough stirring. The biphasic solution was transferred into separatory funnel where the initial separation yielded aqueous solution and a yellow organic solution where benzyl was, yeah. To ensure complete extraction, the aqueous was returned to the separatory funnel and extracted twice more with fresh 10 milliliter portion of ethyl acetate. Each time the funnel was shaken vigorously, allowed to separate all ethyl acetate completely. All ethyl acetate lays onto the organic phase, aqueous phase, copper complex. Okay. After dissolving the mixture, two distinct layers formed: a yellow organic phase and a blue aqueous phase. During the multiple extraction, each addition of 10 milliliter ethyl acetate transferred more yellow color. Oh, after dissolving the mixture, two distinct layers formed: a yellow organic phase and blue aqueous phase. During the multiple extraction, each addition of 10 milliliter acetate transferred more yellow. Oh shit! It's a new room. Oh, I haven't checked the room. God damn it! God damn it! God damn it! Timetable 2025 summer. Does someone know? Tell me, bro. Someone know. HT. Let me search. Okay. Should be near HS5, I guess. Could be near. Oh, it's a lot. It's a lot. Observation, absurd, dissolving the two distinct layers formed the yellow. Okay, interpretation, the color difference clearly demonstrated the solubility properties. Benzyl yellow color migrating to organic phase confirms its non-polar character, while persistent blue aqueous phase verified CuSO4 polar nature. As pale blue aqueous solution indicating near complete benzyl removal, confirming the success of separation method. Procedure: the combined yellow organic phase were washed with 25 milliliters saturated brine to remove residual water, then dried by adding anhydrous sodium sulfate. After filtering through cotton plug, the solution was distilled in a round bottom flask until 5 to 10 milliliters of yellow benzyl solution remained, with yellow vapors forming at the end. The concentrated solution was cooled to room temperature for recrystallization. The crystallized benzyl was then collected by vacuum filtration and washed with small amount of 2:1 ethanol and water. We're talking about benzyl, which is part of the organic phase. Benzyl crystals, benzoic acid crystals. So this undergoes recrystallization setup. Which is the recrystallization setup? This is the recrystallization setup. This is the vacuum filtration setup. This is the distillation apparatus setup. And I believe combined yellow organic phase were washed with 25 milliliters saturated brine to remove residual water, then dried by adding anhydrous sodium sulfate. After now that's benzyl. I need iodine. There's no iodine. Yeah. Aqueous phase was filtered over a cotton plug to remove solids and distilled until 5 to 10 50 to 5 10 to 15 milliliter remained, avoiding crystallization. The flask was removed from heat and cooled under stirring. 10 to 15% ammonia solution and 25% 10 to 15% ammonia solution and 25 milliliter ethanol was added. The mixture was cooled in water bath for 10 minutes to induce crystallization. The crystals were collected by vacuum filtration, washed with 1:7 mixture of ethanol and 25% ammonia, transferred into a test-stirred snap cap bottle, and dried it in a desiccator. The filtered aqueous solution was clear blue, and upon distillation it becomes darker without any crystal formation. Adding 25% ammonia solution caused a light blue precipitate to form initially, which dissolved. The filtered aqueous solution was clear blue, and upon distillation it becomes darker without any crystal formation. Adding 25% ammonia solution caused a light blue precipitate to form initially, which dissolved with further addition, resulting in a dark royal blue solution. After adding further addition, resulting in a dark royal. After adding ethanol and cooling, a dark royal blue. Did I write it 2 times? Resulting in a dark clay-like, a dark royal blue clay-like powder began to form as it dried. The product became more powdery, and less cohesive. The final solid was dry, dark royal blue powder with a slightly clayish texture when damp. Interpretation, including chemical equation: upon distillation, the copper 2 sulfate solution become more concentrated, but no crystals formed. Addition of 25% ammonia caused a light precipitate of copper 2 hydroxide. How does ammonia give hydroxide? Those make sense. With excess ammonia, the precipitate dissolved, forming deep royal blue. Okay, now we talking. Now we talking. Forming a deep royal blue tetramine 2 sulfate complex. Tetraamine copper 2 sulfate complex. No. Upon sulfate monohydrate. CuNH34 SO4.H2O. Oh, the final product appeared as dark royal blue clay-like powder that becomes powdery upon drying. I don't know that for sure, but yeah, I guess it becomes powdery. Clear light blue solution, deep blue solution, dark blue crystalline solid. Some formula of copper 2 complex. Not gonna lie, I got 45, no, 43 minutes, 42 minutes to get the fuck out of here. What should I do? At least complete reading, yeah. Tetramine copper 2 sulfate monohydrate, that's the final product. NH3, 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 2 plus. SO4. SO4. In initial, okay, number of moles given mass by given molar mass gives number of moles. N theoretical would be uh, given initial given mass by number of moles, I guess. M theoretical equals N theoretical. Oh no, that's different. That's something else. 249.72. The fuck is that? Now it's time for the last section, section 6. Section 6. Oh, whoa, 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 whoa. I don't have section 6. It's all written. Oh no. The purpose of the experiment is to perform a multi-step copper cycle where copper is dissolved, converted into various salts, and finally reduced back to its metallic form. This demonstrates key reactions including oxidation, precipitation, dissolution, and reduction, while also emphasizing the importance of quantitative analysis and yield calculation. Devices used, beaker, chemicals used, copper. You get the beaker copper. No? Okay. 1 gram of copper powder was weighed and dissolved in 21 milliliters of 4.5 moles of nitric acid. After reaction complete, 110 milliliters of deionized water added to dilute the solution. 3 moles of NaOH solution was prepared by dissolving 3.64 grams of NaOH in the 30 milliliter water and then slowly added to the copper nitrate solution. Under stirring, the resulting precipitate was heated. The black solid was transferred to another beaker and rinsed twice with 200 milliliters of boiling deionized water. The first decant. Oh, those were all observation. Okay. A 6 mole of prepared by mixing 5 milliliters of concentrated so To dissolve copper oxide, resulting in the blue copper sulfate solution with residual black CuO suspended on top. A total of 3.51 grams of zinc dust was added to the two steps, 2.51 grams initially and 1 gram later, to reduce the Cu2 plus ions. After reduction, the supernatant was decanted and residue was treated with 5 milliliters of deionized water and 10 milliliters of concentrated hydrochloric acid. The remaining copper was then wash sequentially with 5 milliliters each of water, ethanol, and acetone using vacuum filtration. So, using vacuum filtration, what am I doing? How can you waste time? Why? How, Josh? How do you waste time? To do all the chores, and if you support this, the solution of copper and nitric acid produced a vigorous reaction with the evolution of brown gas, which you should not breathe. Acetone CH3C, CH3 double bond O, H2O, Now, S star O C NH3 2 plus. The hell? What? There's two? Oh, it was the first one. Okay. I'm actually really scared. Please, Lord, please just let me pass. I don't want to do this again. If I do this again, I don't want to do this again. I don't want to do this again. I want to be. Deep Seek. Did I just? No way. I just closed Deep Seek. Uh. So tell me which waste sections do the compounds involved from section 1 to 6 go after the experiment. Why? Why is it always there? Why is my headphones there? Why is it always there? You know, I am not someone who gets scared for exams, but when I learn for the exam, when I put in work for the exam, I hate it. That's where the tension comes up. Iron in dichloromethane solution. Procedure must be treated with sodium thiosulfate until colorless. Yeah, you know. So dichloromethane should be treated with sodium thiosulfate. Acetone is an organic solvent. Pure compound 1, acetone collection container. Purified benzoic acid. Iodine, sodium thiosulfate. Remember, Tetraamine copper to sulfate. Copper complex container. Copper complex, okay. Can you see it? Oh, you could see it. We're fast, boy. We're fast. We're real fast. From the looks of it, I don't know. Acidic waste container. Acidic waste. Acetone, ethyl acetate, ethanol all goes to organische Wast. When in doubt, ask. I can ask, it's an exam. Bitch, I can ask. Pure benzoic acid, iron, copper, metal. Oh yeah. Oh, it's actually works pretty. Stichloromethane, don't. Harmful if inhaled. Harmful if inhaled. Dichloromethane. So it should be fume hood, respiratory carcinogen. What is this? Corrosive. Okay. Hydrochloric acid, nitric acid. I think most of the acids are Oh, wait. Not just acid. Sodium hydroxide, ammonia, flammable acetone, ethanol, ethyl acetate, zinc dust, aluminium powder, toxic. What's toxic? Dichloromethane, iodine, nitrogen gas, ammonia vapor. So before here it was, that's aluminium. Okay. Oxidizing agents. Okay. Nitric acid. Okay. Water, potassium permanganate. What else? What is this? Potassium permanganate can cause fire. So these are what's toxic. Copper salts are toxic. Okay. Uh, hydrochloric acid, nitric acid, hydrochloric acid, nitric acid. What else? What else? What else? Sodium hydroxide, ammonia solution. Oh, that's where I saw ammonia. So ammonia is corrosive and toxic. You know what I'm saying? You know what I'm saying? I'm gonna leave in 7 fucking minutes. And I gotta eat something, dude. I could read my note I prepared for myself. It's too big. Nah. Section 1, extraction and measurements of volume. Main goal to learn the fundamental lab techniques for handling liquids and equation and separating mixtures. Okay, extraction using separating funnel to separate iodine from water. Comparing iodine using separatory funnel to separate. Okay, so volume measurement, testing the accuracy of different lab tools by measuring, weighing water, observing that the volume of water acetone mixture has less than of its individual volumes, preparing a precise sugar solution with its density and refractive to estimate the sugar in given beverage, distillation of binary mixture to separate two liquids based on their thin boiling point using simple distillation key activities, assembling a distillation apparatus using round bottom flask, condenser, and thermometer. Yeah, distillation apparatus do need, okay. Separation, distilling a mixture of acetone and water, collectively different fractions as temperature changes. What? Okay. Analysis, measuring the refractive index of each fraction to check the purity and efficiency of the separation. Recrystallization, filtration, and sublimation to learn different methods for purifying solid compounds. Key activities: purifying impure soil benzoic acid by dissolving it in hot water and letting pure crystals. What was the principle of recrystallization? Uh, pa, principle of recrystallization. If you ask me that, I'm gonna plead the flip. I'm gonna plead the fifth. So purifying impure solids by dissolving it in hot solvent and recrystallizing it so less impure, I guess. Oh, you can see myself through my glasses. Yeah, you can. Okay. What else? Vacuum filtration is isolating purified crystals from the solution. Sublimation, purifying impure iron by heating it so it turns to vapor and re-solidify as pure crystals onto a colder surface. That's sublimation. Heating. Yeah, purifying impure iron by heating. Yeah. Oxidation reduction reaction. Oxyhydrogen test, generating hydrogen gas and testing it with flame. That was the splint test, right? Redox amphoterism is substances substances that acts as oxidizing and reducing agent given based on the reaction. What else? What else? Redox, amphoterism, oxygen preparation. What's that? Making oxygen gas from pure hydrogen peroxide. Autocatalysis, observing a reaction that speeds up the. I don't remember the formula. Separation and copper complex. This is where you make the tetramine copper 2 sulfate hydrate with copper 2 sulfate hydrate. Section 6 copper cycle to perform a series of reaction that transforms copper metal through various compounds and various salts and back to copper, demonstrating a cycle. A cycle. Now, nitric acid, nitrate to hydroxide, hydroxide to oxide, oxide to sulfate, sulfate to pure copper. We come full circle. Now glassware. Filtering flask. Oh shit, glassware. Filtering flask, filter crucible, volumetric flask, filtering adapter, reduction adapter, filtering flask, filter crucible, volumetric flask, inlet conduit, quick fit, test tube with sidearm, the glass rod with policeman, distillation bridge, Liebig condenser, separator funnel, hot water, cold water goes in at the bottom for both distillation and recrystallization setups. These are cheap ass glasses I got from a theater. What did I say that? Vacuum filtration setup. That's the rubber cone. There's the filtering flask, right? Filtering adapter. God damn it! Filtering adapter. Come on. Filtering adapter. That's the filtering adapter. Filter crucible. That's the sublimation setup. It's 50, bro. I gotta say, peace out. Well, people, let's see how the exam's gonna go. My real prediction is gonna be it's gonna go good, but who knows? Maybe it's gonna suck. Maybe it's gonna suck. Let's see how it goes. I think the exam should be done in about 1 hour 30 minutes. So I'll be back in a while. And I got a plan for the next exam. So peace out, YouTube. There's no tube. Yeah, peace out.